So we totally hit this in our explanations here, but if we're looking at the equation a plus b cosine theta equals r, and we're looking at the relationship between a and b, if a over b is less than 1, we'll think about what that is saying essentially. In a way, it's saying a is less than b. Well, if that happens, if a is less than b, we're going to end up with a graph that crosses the axis like that. So we're going to cross the pole a couple times and we're going to end up with that negative section there. That negative section is giving us a limacon with an inner loop, something like that when a is less than b. If we look at the situation when a over b equals 1, essentially saying a equals b, well then if you look at that graph, that's when we're going to have a rectangular graph where we just simply touch the axis at one spot right there, and that is going to give us our cardioid right there. Oh, the first one, did I say it? I said limacon inner loop. Wow, that could not be sloppier. Limacon with inner loop. Can you read it? I don't know. Was it worth writing? I don't know. Here's a cardioid right there. And then the last one I have you think about here, when that ratio a over b is between 1 and 2, in that instance, we are going to get a graph that does not have any zeros and consequently does not have any negative values as well. And then, or maybe something like that, I don't know, whatever. But the point is, when you do that, you're going to get a dimpled limacon right there. And there is actually a fourth scenario right here, the scenario where a over b is greater than 2. If that happens, then you get what is called a convex limacon, which kind of just looks like a frumpy circle, but it doesn't have that little dimple right there. Those are the four situations. So just by looking at an equation, you can actually tell a lot about the corresponding limacon.